Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the ionization energy tricks nana NEET preparation series day 1 11th class topic classification of elements and periodic properties nana. Okay nama, this is the third lesson 11th class first PUC. Clear students? So in the last nana video I discussed ionization energy. Okay, now what about ionization energy? What is the definition, ionization energy definition, and next what are the factors affecting the ionization energy? That all topics I discussed in the previous video students. Now in this section I am going to discuss about how it is changes in the periods and groups, what are the exceptions are there, how to find ionization energy, that all I am going to discuss students. Okay nama. Now see students, here variation of ionization energy in a period. First in period how it is changes I am going to discuss. Okay na. So variation of ionization energy in a period. Okay, in a period how it is changes students, variation of ionization energy in a period. So we know that in a period from left to right nana atomic size decreases. Are you clear? Atomic size decreases from left to right, correct? So here left to right atomic size in periods. Okay na, atomic size in periods decreases students. Are you clear? Atomic size decreases means what students? Big to small, correct? I am taking here, this is the big atom, big to small. Okay, big to small. Atomic size in periods decreases. So here this is the nucleus, this is the last shell. Suppose this is the last shell of an atom, this is the last shell of an atom, valence shell, and here nucleus is, it is here between the nucleus and the valence shell, here distance is more, correct? Here distance is more, here distance is less. Are you clear? Whenever distance is more, what will happen students? Nuclear attractions. Here suppose electron is there. Okay, here also electron is there. Clear? Electron is there. So to remove this electron, here less energy is required students, because here nucleus is far to the valence shell. Are you clear? So that's why it is here distance is more. Whenever distance is more between the nucleus and the valence shell, nuclear attractions are less. Are you clear? Distance more, here what I told you, distance more, and next nuclear attractions on valence electrons students. Distance increases, nuclear attractions on valence electrons decreases. Are you clear? Here distance is less between the nucleus and the valence shell. So distance less, nuclear attractions more. Are you clear? Distance here in this case distance less. So that's why here in this case nuclear attractions are more. Nuclear attractions, are you understanding? Nuclear attractions are more. Nuclear attractions are more on valence electrons. Clear this one, on valence electrons. Understanding nana? Nuclear attractions are more on valence electrons. Here attractions are less. Nuclear attractions are less. Here nuclear attractions are more. Whenever attractions are less here, then ionization energy to remove the electron, here very less energy is required, because nuclear attractions are less. So that's why ionization energy in this case it is less. Here in this case ionization energy it is more, because nuclear attractions are more on valence electrons. So attractions are more, it is not ready to lose the electron. So that's why we have to supply more energy students. That's why ionization energy is more. So that's why from left to right, here less, here more. So from left to right what we can say students, finally here less, here more. That means ionization energy increases. Clear this one? ionization energy increases. Understanding? Here decreases, here increases. Small here more, small to big, that is increases. Are you clear, students? So left to right atomic size in periods decreases, students. Then what will happen? Ionization energy decreases. Sorry, ionization energy increases. Atomic size decreases. Ionization energy, sorry amma, increases. Clear, students? Ionization energy increases. Clear this one? Ionization energy increases. Now I am taking one example, students. Here first year which period? Second period elements I am taking. Okay na? Second period elements. Okay, now see, students, example second period elements I am taking. What are the second period elements, Nana? Second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Correct? So I am taking the elements: lithium, sodium, period elements na: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so these are the second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. If I take second period elements, Nana, what about ionization energy values, students? Here ionization energy values, if you see ionization energy values here, if you, because in the periods what I told you, students, ionization energy increases from left to right. Correct? Increases from left to right in periods. Understanding? So left to right, ionization energy increases. Okay, ionization energy increases means here what is the order, students? Ionization energy increases means what? Increases means small to big. Okay na? So that's why less than, less than, less than, less than, less than. Are you clear? So left to right ionization energy increases, but this order is correct, students. This order is wrong. Are you clear? This order is wrong, students. Why it is wrong? This bit is very very important, students. It is number of times repeated questions in the competitive exam, students. Very very important bit, this one, second period elements. Are you understanding? It is very very important. Okay, now see, students, why this is order is wrong. I told you ionization energy increases from left to right. Here increases means left to right. Second period elements lithium to neon increases, but this order is wrong. Why it is wrong, students, in the periods? Because beryllium, if I take beryllium electronic configuration, what, students? Just I am writing only beryllium electronic configuration. Atomic number, how much? Atomic number, first I am writing atomic number 4. Okay, atomic number 4. What is electronic configuration? 1s2 2s2. 2s2 means here 2 electrons in 1s, 2 electrons, means it is completely filled electronic configuration. Are you clear? It is a completely filled. Are you clear, students? It is a completely filled electronic configuration. Completely filled electronic configuration. So that's why we know that half filled and completely filled orbitals are more stable. So that's why this electronic configuration is more stable. That means these electrons are strongly bounded by the nucleus. So that's why nucleus is not ready to lose the electron. In this case of beryllium, students, we have to supply more energy to remove the electron. Are you clear? So that's why when compared to boron, beryllium is having the more ionization energy. Okay now, and coming to the nitrogen, students, in the case of nitrogen, here if you see the nitrogen atomic number, how much, Nana? Atomic number nitrogen is 7. Atomic number 7 nitrogen. What about electronic configuration? 1s2 2s2 1s2 2s2 2p3. Correct? 3 plus 2 5, 5 plus 2 7. So 1s2 2s2 2p3, it is the electronic, it is the valential electronic configuration. Are you clear? It is a valential electronic configuration, so that's why it is having the, it is in 2s 2 electrons, in 2p 3 electrons are there, 1 2 3. That means valential electronic configuration, it is a 2s is completely filled, 2p is which one, students? 2s is completely filled. Okay, it is completely filled. Okay, this one is half filled. So that's why we know that completely filled and half filled orbitals are more stable. So that's why nitrogen is having the more ionization energy, because it is more stable. So from the stable elements, we cannot remove the electron, so we have to supply more energy to remove the electron, students. So that's why it is stable, it is stable. Okay now, so just you take here valential electronic configuration 2s2, it is a completely filled electronic configuration. It is completely filled, it is half filled, so those are stable, students. It is stable electronic configuration, and it is also having stable electronic configuration. Are you clear? Stable electronic configuration. So that's why when compared with oxygen, nitrogen is having the more ionization energy. Are you clear? Nitrogen is having the more ionization energy in this case, and in this case you have to remember, students. Okay now, beryllium and boron, which is having the more ionization energy? Beryllium is having the more ionization energy. And nitrogen and oxygen, which is having the more ionization energy? Nitrogen is having the more ionization energy. Are you clear? So that's why what is the final order, students? What we can write final order? See here, lithium after beryllium is lithium after boron after beryllium, because beryllium is having the more ionization energy than boron. Are you clear? So that's why what is the order you will get? Lithium less than boron, less than beryllium, less than, okay, first boron, next beryllium, next nana carbon, as it is in nitrogen and oxygen. First which one is having less? Oxygen. Next nitrogen is having more ionization energy, and next fluorine, next neon. Are you clear? Fluorine, neon. So because neon is the noble gas element, stable element, so that's why it is having the more ionization energy. So this is the correct order. Are you clear? So this is the correct order, students. Understanding? So this is the in the case of second period elements. Now I am taking the third period elements also, students. Third period element. Now what is the third period element, students? I am taking now third period elements. Okay, third period elements. Left to right I am taking. What are the third period elements, Nana? Sodium. Okay, sodium, aluminium, sodium, magnesium, third period, sodium, magnesium, aluminium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Are you clear? So these are the third period elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now what I told you, left to right atomic size, what will happen? Left to right, atomic size decreases, ionization energy increases. Correct? So this is the left to right. Understanding? Left to right atomic size decreases, ionization energy increases. So ionization energy increases means it is less than. So this is the correct order, students. Less than, less than, less than, less than, less than. It is it correct? No, it is wrong order. So what is the correct one? Because we know that aluminium is having the, it is aluminium, if I take, it is having the electronic configuration atomic number 13, atomic number 13 electronic configuration 1s2 2s2 2p6 3 2s2 2p6 3s2 3p1. Yes, 3s2 3p1, it is having the electronic configuration 3s2 3p1. This is aluminium. Now coming to the magnesium, students, atomic number is 12. Atomic number 12. Electronic configuration 1s2 2s2 2p6 3s2. Okay, valence shell electronic configuration is 3s2. That means it is having the completely filled electronic configuration. It is having completely filled electronic configuration. It is stable electronic configuration. That's why ionization energy is more. Okay, so here magnesium is having the more ionization energy than aluminium. Are you clear? So magnesium and aluminium, which is having the more ionization energy, students? Magnesium and aluminium. Magnesium is having the more ionization energy. Are you clear? Magnesium is having the more ionization energy than aluminium. And in the case of here phosphorus and sulfur, phosphorus is having the atomic number 15, atomic number 15, electronic configuration 1s2 2s2 2p6 3s2 3p3. That means in 3s2 2 electrons, in 3p how many electrons? 3 electrons. It is a half filled electronic configuration. It is completely filled, it is half filled. That's why its electronic configuration is stable one. So that's why ionization energy is more. Ionization energy is more, students, than sulfur. So in this case, students, phosphorus and sulfur, which is having the more ionization energy? Which is having more ionization energy? Phosphorus is having the more ionization energy. Are you clear? Now what is the correct order, students? What is the correct order? See here, sodium. Sodium after which is having the more ionization energy, students? Here magnesium. Sodium is less than, magnesium is less than aluminium. No, aluminium after magnesium. Are you clear? Sodium less than, aluminium less than. Are you clear? Magnesium less than, silicon less than, sulfur less than phosphorus. Sulfur less than phosphorus. Are you clear? Less than phosphorus, less than chlorine, argon. So this one is the correct order. Are you clear? This one, it is the correct order in the case of second period. Understanding? Now I am going to discuss about the variation of ionization energy in a group. Now see, students, variation of ionization energy in a group. In a group, how it is changes. Variation of ionization energy in a group. So in groups, students, from top to bottom, ionization atomic size from top to bottom. Okay, in groups, nana, groups from top to bottom, atomic size increases. Correct? Atomic size increases, ionization energy decreases. Okay, and atomic size increases, ionization energy decreases. Top to bottom increases, atomic size increases because number of shells increasing, atomic size increases. Increases means small to big. Correct? Small to big one. Small to big from top to bottom. This is the nucleus. Okay, this is the nucleus. This is the distance. This one is distance from this is the atomic size. Now the distance between the nucleus and the valence shell is nothing but atomic size or radius. So here, from here to here electron is there, here valence shell electron. Now here distance is less. Distance less means what is happening, students? Distance less. Distance less means nuclear attractions are more. Are you clear? Nuclear attractions are more on the electrons, valence electrons. Nuclear attractions more means ionization energy, it is more. Because nuclear attractions more, that's why this nucleus is not ready to lose electrons. So that's why we have to supply more ionization energy. More energy have to supply to remove the electron. So that's the ionization energy is more. Now in this case, tell me, students, here distance is more. Correct? From here to here distance is more. Distance more. What about nuclear attractions on valence electrons, students? Less. That's why ionization energy is less. Because nuclear attraction is less, that's why we can easily remove the electron. Less energy is enough, ionization energy decreases. So from top to bottom, here it is more, here it is less. More to less, from top to bottom, more to less is nothing but ionization energy. Finally we can say that ionization energy decreases. Are you clear? Ionization energy, what will happen? Decreases. Are you clear? Here more, here less. Big top to bottom decreases. Are you clear, students? It is decreasing. Ionization energy decreases. Okay, Nama. Now I am discussing in the D block elements 3D, 4D, 5D series. What about in 3D, 4D, 5D series, students? 3D, 4D, 5D series. Okay. 3D series top to bottom I am taking Nana. 3D series, so 3D, 4D, 5D series. So 3D, 4D, 5D series, 3D series top to bottom na. So I am taking as 3D, 4D, 5D. Clear? Top to bottom, what will happen? Top to bottom, atomic size increases, ionization energy decreases. Atomic size increases, ionization energy decreases. That means from top to bottom, ionization energy decreases. Decreases means what, students? 3D is greater than, 4D is greater than 5D. Now this order is correct one, students. Is it correct? 3D, 4D, 5D, because ionization energy, what will happen? Ionization energy decreases. Correct? 3D to 5D. Okay, decreases means big to small. That's why greater than symbol. Big to small. Is it correct, this order? No, it is wrong order. Okay, Dama. So because in first which one will come? 5D series will come. What is the correct order? 5D greater than 3D, 5D greater than 3D greater than 4D. Why 5D is first? Why 5D? Ionization energy is more, students, because of lanthanoid contraction. Are you clear? So because of lanthanoid contraction, students, lanthanoid contraction, its ionization energy is more. Are you clear? Ionization energy, what will happen? Ionization energy is more. Clear, Nana? Ionization energy more. Because 5D series, in the 5D, which elements will be there? Lanthanoids are there. So that's it. Because of lanthanoid contraction, atomic size decreases. Atomic size is smaller than 3D, 4D. So that's why its ionization energy is more. Are you clear? So this is a 3D, 4D, 5D series in the case of D block elements. Okay, now I am going to discuss about the 13th group elements, Nana. Now see, students, 13th group elements, if I take 13th group elements, 13th and 14th group elements, Nana, there are some exceptions, students. 13th group elements. Are you clear? There are some exceptional cases are there. Exceptions. Okay. In which group? 13th to 14th group, Nana. First I am going to discuss about the 13th group elements. What is the exception? Now what are the 13th group elements, students? Boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. Okay, from top to bottom, what will happen, students? We know that from top to bottom, atomic size increases, ionization energy decreases. Correct? Ionization energy decreases. So boron to thallium, atomic size increases, ionization energy decreases. Decreases means what? Big to small. Correct? Big to small. Ionization energy decreases. Decreases means what, students? Big to small. What is the symbol you have to use? Greater than symbol you have to use. Is it correct order, students? 13th group elements, P block elements. Is it correct order? This is which block? P block elements. Are you clear? This is P block exception. Okay. So here, is it correct order? No, it is wrong order, students. Are you clear? It is wrong order. What is the correct order, students? Because here thallium, if you observe the electronic configuration, students, thallium is having the F14 electronic configuration. F14 electronic configuration will be there. And coming to the gallium, students, are you clear? Gallium is having the D10 electronic configuration. D10 electronic configuration configuration? It is F14 electronic configuration. Are you clear? So what is the electronic configuration? It is 13th group kada electronic configuration ns2 np1. So gallium, if you take here boron, helium, neon, argon. So that means what is the electronic configuration? We can write argon. What will come here? Second shell, it is a third shell. So that means here what is electronic configuration? You will get gallium, boron, aluminium, gallium, indium, thallium, argon, helium, neon, argon. Okay, argon 3s2. What is electronic configuration? Here boron is helium 2s2 2p1. Correct? Boron, helium 2s2 2p1. This is 3s2 3p1. Here what you will get, students? 3d10 4s2 4p1 you will get. That means d10 electrons are there here. Here if I take thallium, students, here what you will get? This is 3d10. Here 4d10. Here 4f14 will get. Argon, krypton, xenon 4f14, 5d10, 6s2 6p1. This is the electronic configuration. So that's why here which electrons are there? F14 electrons are there. We know that F14 electrons and D10 electrons are poor shielders. Are you clear? These are poor shielders. So that's why what will happen, students? D10 and F14 both are poor shielders, Nana, poor shielders. So that's why atomic size is decreases. Are you clear? Its size is very small, and next gallium size is small. F electrons are still very far to the nucleus. So that's why they are very poor shielders when compared to D10 electrons. So that's why what is the correct order, students? Boron greater than, next thallium greater than gallium, because its size is small. Are you clear? Poor shielders. So that's why they cannot act as a screen between the nucleus and the valence electron. So that's why atomic size is decreases. Atomic size decreases means ionization energy more. So that's why thallium, after that gallium. Next, as it is, you have to take Nana, aluminium, indium. This is the exception case, students. You have to remember this order. Okay. This is the 13th group elements exception. Clear this one? 13th group elements exception, students. Now I am taking the one more exception, 14th group elements. So what about the 14th group elements? See here, 14th group elements. What about the 14th group, Nana? 14th group elements. What are the 14th group elements, students? Carbon. 14th group elements are, Nana, carbon, silicon, germanium, tin, lead. So here I am taking the 14th group elements, carbon, silicon, germanium, tin, lead. Now we know that 14th group elements from top to bottom atomic size increases, ionization energy decreases. It is a exception case, students. 13th and 14th group only exception. There is an exception. So that means ionization energy decreases, correct? From top to bottom atomic size, top to bottom atomic size increases, ionization energy decreases, correct? Ionization energy decreases. Decreases means big to small. That means greater than symbol is this one. This order is correct one, students? No, it is wrong order. What is the correct order, students? What is the correct order? Carbon greater than, silicon greater than, germanium greater than, lead greater than, tin. It is the correct order. Are you clear? So this is the correct order, students. Only there is an exceptions in the 13th and 14th group, Nana. Okay, na? Exceptions only. There are some exceptions in the 13th and 14th group elements. Only in two groups we can observe the exception, students. Remaining groups, if you say 15th, 16th, 17th and 18th groups, Nana, there is no exceptions. Are you clear? From 15th, 16th, 17th, 18th. There is no exceptions. Are you clear? No exceptions. So that means what? From 15, 16, 17, 18, top to bottom, what will happen? Top to bottom, atomic size increases, ionization energy decreases. This is the case, this trick you have to remember, students. In the case of 15, 16, 17, 18, there is no exceptions in the 15, 16, 17, 18th group. Only there are two exceptions in the 13th and 14th group. These orders you have to remember, students. Are you clear? So this is about the variation of ionization energy in periods and groups, Nana. In periods and groups. Now see, students, and one more bit I am going to discuss, Nana. See, students, successive ionization enthalpies. Successive ionization enthalpies. Here ionization enthalpies values given, students. Successive values. Okay, first enthalpy, first ionization energy value, second, third, fourth, fifth given. These ionization energy values belongs to which element is asking question. So these type of bits are very important for the competitive exam, students. Here how to identify which element is showing these ionization enthalpy values. Now see, students, if I take here first ionization energy, after that second ionization energy, it is having the more difference energy gap. Here this is 577, this is 1810, correct? That means here more energy is required. Okay, and after that here 1800 nunchi 1800 to 2750, here also more energy is required. But if you observe here 2000 to 11,000, there is a more difference. Nearly how much difference, students? Nearly 8,000, that much difference will be there. More difference is there. So that means here I think here the atom is, I think it is stable. That's why we are supplying more energy to remove the electron, students. Now I am taking the example aluminium, students. Aluminium, suppose aluminium. What is the aluminium atomic number, students? 13. 13 means what is electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p1. Correct? 3s2, 3p1. So in the first ionization energy, students, atomic number 13. Now here 13 electrons are there. Here how many electrons lost in the first ionization energy? IE1. One electron lost. Here one electron lost. So that's why it is having 1s2, 2s2, 2p6, 3s2 electronic configuration. Here how much energy is required? This much energy is required, suppose. Okay, it is IE1. So by loss of electron here, what is its atomic number? 12 electrons are there. Now in IE2, second ionization energy. Now see, students, here 12 electrons are there. Now one electron lost here in the second ionization energy. Then what is electronic configuration? Now if you observe this 3s2, it is a stable electronic configuration, correct? It is a stable electronic configuration. So that's why here by 12 electrons means which element it is getting, students? 12 means magnesium. Clear? It is a magnesium, students. Are you clear? So in IE1, IE1 means after loss of one electron, here what is the energy IE1? This is 577.5. I am taking example IE1. So here after loss of one electron, it is getting the magnesium electronic configuration, that is 1s2, 2s2, 2p6, 3s2. Are you clear? Means how many electrons, Nana? 12 electrons. Are you clear? Now IE2 I want to find. IE2. So from 3s2 is what, students? It is completely filled electronic configuration, so that's it is stable. So that's why here more energy have to supply, then only the electron we can remove from the valence shell. So that's why here whenever lost one electron, here more energy is required, students. So that's why here 1000 energy is required. More energy required. So after loss of one electron, it becomes 1s2, 2s2, 2p6, 3s1. Okay, 3s1. Here one electron lost. Here total 12 becomes 11 electrons. And this is magnesium. This is the electronic configuration of sodium. Correct? 1s2, 2s2, 2p6, 3s1. Clear, Nana? This one. Now IE3 I am going to calculate. Now IE3, here what is here one electron lost, 3s1 in IE3. So what it will get electronic configuration? 1s2, 2s2, 2p6 it will get. That means 11 electrons become 10 electrons. By loss of one electron, then it becomes 10 electrons. Then it is the electronic configuration of neon. Are you clear? It is electronic configuration of neon, students. Clear this one? So neon. So that's why from here to remove the electron, now we see students, this is the electronic configuration IE3. So that's why here some energy is required, that is this much. Now coming to the IE4 what students, here we are removing the one more electron, so that's it, 10 electrons becomes 9 electrons. Here 1s to 2s to 2p6 is, it is stable electronic configuration, 2 3 4 5 6, it is a stable electronic configuration, it is a noble gas element, that's it is more stable, ionization energy is more. Are you clear? So to remove the electron from the neon element, from the stable electronic configuration of nearest noble gas element neon, here more energy is required students from this one. So that's why IE4 value is more. Are you clear? So IE4 is more, because to remove this electron here more energy have to supply. Are you clear students? So that's why here difference third to fourth ionization energy they given, there is a more difference gap is there, nearly 8,000 gap is there. Are you clear? So that's why here from third ionization energy to fourth, here to remove the electron from the stable electronic configuration more energy is required. Are you clear students? This is successive ionization enthalpy nana. Clear? So this is about the ionization enthalpy students, ionization enthalpies. Clear this one? Now see students, one more question. Okay, now important bit nana. So what is the question nana? Beryllium, boron, carbon, nitrogen. Beryllium, boron, carbon, nitrogen. Okay now. So IE2 value, IE2 order is asking students. IE2 order. What is the IE2 order question? Beryllium, boron, carbon, nitrogen. See students, these elements are which period elements nana? These elements are second period elements, correct? So we know that second period elements, there is an exception, correct? So what is the correct order students? Actually what is the order? Lithium less than, because left to right atomic size decreases, ionization energy increases, that's why less than condition. Lithium after boron, beryllium, next one carbon, nitrogen, oxygen is having less ionization energy than nitrogen, oxygen, nitrogen, fluorine, neon. This is the correct order, correct? Already we discussed in the last topic students, this order, correct, in the IE2 order. Okay, see nana, here we discussed already. Where nana? Here, correct? Lithium, beryllium, boron, correct? This is the correct order. Beryllium is having the more one and nitrogen is having the more. So this is the correct order students. In this orders nana, okay na. So from this order you just write this correct order nana: beryllium, boron, carbon, nitrogen. First IE1 you are writing. Okay, IE1 order. What is the IE1 order here? Beryllium, boron, carbon, nitrogen. Which is coming first? Beryllium. First boron will come, correct? Boron less than beryllium, less than carbon, carbon after nitrogen is there. This is the correct order. Are you clear? So these are the given elements. So according to this order, I am writing this order. This is IE1, correct? So IE1 means already one electron lost. Are you clear? One electron, understanding, one electron lost. IE2 we have to write order. So boron electronic configuration, what students? Hydrogen, helium, lithium, beryllium, boron 5. 5 means 1s2, 2s2, 2p1. This is 2s2, 2p2. This is boron over. This is beryllium nama. Hydrogen, helium, lithium, beryllium. 4 na, that means only 2s2. 1s2, 2s2. Carbon means 6 atomic number. 1s2, 2s2, 2p2. 2s2, 2p2. Nitrogen is 2s2, 2p3. This is the valential electronic configuration. 2s2, 2p1, 2s2, 2s2, 2p2, 2s2, 2p3. Now see students here. 2s2 is the completely filled electronic configuration. It is stable. Are you clear? That's a more ionization energy is required to remove this electron, beryllium. So from here, if you want to remove the electron, more energy is required. But it is also stable electronic configuration. 2s2, 2p3. Are you clear? 2s2, 2p3 nana. Clear nana this one? 2s2, 2p3. clear? Now see students, here by loss of one electron, what it will get by loss of one electron? Now we remove one electron from each element. Now here what will get? 2s2 you will get. Are you clear? So here 2s2, it is stable element, Nana. It is stable element. So here more energy is required. So that's why here electronic configuration is 2s1 after loss of electron. Then it will get here, from here one electron lost means it will get 2s2 2p1. It will get 2s2 2p2. Are you clear? 2s2 2p2. Now which is the more stable, students? Here 2s2 means what is actually electronic configuration? 2s2 1s2 2s2 arrow beryllium. This is this only, na, beryllium. So this element arrow beryllium. Next 2s1. 2s1 means 1s2 2s1. 2s1 means which element? Lithium. Are you correct? Lithium. 2s2 2p1. 2s2 2p1 which electronic configuration? Boron. Next 2s2 2p2 which electronic configuration? 2s2 2p2. This is carbon. Now these elements you order right, Nana. In this order just you write electronic order: beryllium, lithium, boron, carbon. Which is having small value ionization energy? Lithium. Lithium less than, next aroma, beryllium. Boron, lithium, boron, beryllium, carbon. This order kada. So lithium, boron, beryllium, carbon. Now lithium element, actually which element this is? Beryllium. So this is the beryllium. Okay, beryllium less than. Boron, actually which element? We got carbon element. Next beryllium, which element we got? Actually beryllium, boron. Okay, this is the boron. Next carbon. So this one, see, carbon is which element? Nitrogen. So this is the correct order. Are you clear, students? How to do it? Beryllium, boron, carbon is asking IE2 order asking. Actually this is the IE1 order. So here these elements according to this order, this is the correct order. Now these electronic configurations, right? Now in the second ionization energy we are removing one electron. So that's why after loss of electron their electronic configurations, right? Okay, now this electronic configuration 2s2 is nothing but which element? Okay, this electronic configuration is similar to which element? That elements you have to write. Understanding? After that these elements you have to observe in this beryllium atom. In this order, according to this order you write fast. After that lithium is nothing but beryllium is nothing but boron nothing but carbon is nothing but nitrogen. This is the correct order, students. Are you clear, Nana? So this is about the ionization energy, Nana. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana. Thank you very much, students.